Hello and welcome to DevelopersHeaven. Today in this video, we are going to write FastAPI, web APIs using FastAPI and PostgreSQL. If you have watched my previous video, I've done a video on how to create web APIs using FastAPI, but there the data is in memory, meaning whenever the server restarts, all the memory, all the data which we have inserted or updated is gone. But this time around, I'm going to connect this to a database so there is a persistent data for us. So to get started, you will need some dependencies. The first thing is the pip install fast API all. So what this all does is it will install all the relevant packages for you along with fast API. So it will install the UECon server to host your web API. It will install Pydantic for creating the models, and it will use Jinja 2 and so on. There are some more packages, but these are the most important one. And we have to install SQL Alchemy. So SQL Alchemy is basically a provider. SQL Alchemy is basically a provider to connect to the databases, and we'll need a PSI-COPG2 package. So this is the driver to connect to the PostgreSQL. So if you're working with SQL Server, for example, then you will need the driver AIOOD ODBC. This is the driver. So we are not worried about this one because we are only working with Postgre. We will just need this one. So this basically is a driver. Take it like this. If you want to unscrew a screw, we will need a screwdriver. So similarly, this is the perfect driver to work with PostgreSQL. And then you will need the PostgreSQL itself. So you can download the PostgreSQL from this URL here. Once you download and install, then you will see a UI like this. And then you'll see a UI like this. Here I've created a database called tutorials, and within the tutorials, if you navigate to schemas and look at the tables is currently empty because I do not have any tables at all. So that is what we are going to do now. Let's get started with the code itself. So what I've done is I've created three files here: the database.py and main Python file and models.python file. The database will hold all the code that is related to the database, and model will have all our tables. You can also name it schemas if you want to, and there is a main file which will actually host our API. I'm not using any complex routing here. It's all going to be in the main.python file. So let's get started with the database.python. So what we need in this database Python is, first thing we want to import from SQL Alchemy, import create engine. So this create engine is a function in SQL Alchemy that creates a connection to the database, right? So it is the starting point to interact with the databases, right? This will just create a connection to the database. And the next thing we want is from SQL Alchemy import from SQL Alchemy.orm import session maker. So ORM stands for object relation mapping. This ORM will let us create the database tables from our Python models, and it will also map the database tables into our Python models. Let's say if I have a table called courses with a title and description, and if I have the exact same model in my Python, when I call the database, it can actually map the database table to the Python model. That's the purpose of this ORM. And this session maker is a factory function that will create session objects to maintain or manage the DB transactions and all the interactions. And this will also ensure that the connections are properly closed after every use. And what we'll need, one more thing, is from SQL alchemy.extension.declarative. I want to import declarative base from here. So this declarative base is the base class for defining ORM. It's like it is more like Pydantic, but this is for the database, Postgres, the database itself, ORM. So it will also map the Python classes to DB classes, and it can also establish easy relationships between tables. So if we have a foreign key and primary key relations between them, it will easily do that for us. Okay. Now the first thing we want to do is create a let this SQL Alchemy know where our database is, right? So I will create what's called a database URL, and there is a format for this one. I will just show you what this format will look like. I will just paste this one here, and I will leave it as a comment. So dialect is basically the database we are connecting to, whether it is a PostgreSQL, MySQL, or SQL Server or Oracle. And the driver is basically the driver that is compatible with the database itself. So if you go back to what I've said before, for connecting to SQL Server, we need AIO ODBC driver, and for Postgres, we need a PS5COPG2 driver. So that is the driver that goes here, and then the username. So in order to connect to the database, we need to provide the credentials, the username, and the password, and at the rate host. This host is where your database is located. So in my case, it is there in my local system itself, so I will specify localhost. But if it happens to be that your database is in a separate location on a server, then you will have to provide the domain name or the IP address for that database, and then the port. Usually if you have not modified anything during installation, PostgreSQL will run on port 5432, but if you change that, then you have to use that relevant port here, and then the database. In my case, the database is tutorials, but if you have created a database, you can do that one here. So I will copy that connection string here, so I can do less typing and more explanation of what I am doing. So in my case, it's PostgreSQL. If you observe, I'm not specifying the driver because it is not really mandatory. SQL Alchemy can work out what database we are connecting to, and it will use relevant driver. If that is not installed, then you will get an error that this particular package is not available. And then Postgre is my username. That will be the default username for anyone working locally. And then this is the password test123. Local host is where that is installed. Like I said, the port and the database tutorials. Now, what I will need is I need to create an engine. So once the engine is created, we can interact with the DB, right, via SQL Alchemy. So let's create the database engine. The database engine is basically the instance of your database. So I will use create engine, and I have to tell the address, which is the database URL. So I'm telling like create engine for this one. Now that we have the engine, we need a session local, another variable called session local. So this is nothing but the session maker, which we have done that one. And what I will do is I will say auto flush is equal to false. I will explain you what this auto flush is, and bind this to what? Bind this to the engine which we have created there. So like I said, session maker is a factory function that will create session objects and to manage DB transactions. We have taken that into a variable. So what this auto flush does is, for example, if you have written two insert commands, two update commands, and you're trying to query those records, SQL Alchemy will flush everything first. It will flush everything to the database. It will not commit it, but it will flush it. So you have the latest data available in the database. But if you don't specify auto flush, if you specify auto flush is equal to false, and it doesn't do that one. By default, it's true, but we can set it to false. So if we set that to false, we have to flush it manually after every command. So the scenarios where we want to set the auto flush to false is when we are working with some complex queries, like my query has like multiple inserts and multiple updates, but I want all of them to be happen at the same time. Then I will set the auto flush to false. And then we need a base. This is like a Pydantic base model, but this is for SQL Alchemy ORM, declarative base. Like I said, this is the base for all our models. And yeah, that's it. We have done with what we need to do in this database file. Now what I will do is I will go into the models file where I will actually create the database tables. All right. So let's go into this models file here. In this models file, I want to import from SQL Alchemy import. I will import the column for creating the column, and I will import integer to specify the data type, and I will also import string, that is another data type. And are there any more data types we need? We only need ID, title, and description, so it will be integer and string. So I don't need any more from there. And from database, the database is nothing but the database.py file you have. And from database, I want to import the base which I have created. Like I said, this is the base for all our models, so I'm just importing it now. Now what I want to do is I want to create a class called courses. This will be my database table. So since this is my database table, it will be extended from the base class. Once we have that one, we can specify all our columns. First thing is I want ID. ID is equal to, this will be a column, the database column. What is the data type here? The data type is integer, and I can set it to primary key. So I will set this to primary key is true. And do we want to index this one? Okay, I will index this lowercase index is equal to true. So what I'm saying is this ID is a column of type integer, primary key, and index true. And I will need another column called title. So for title, it is another column. What do you think the data type is going to be? Obviously string, because this is a text-based one. And shall we index on this one? Yes, because we might be searching on index. So the index will make the search faster. And I need another column called description. DESCRIPT. Description is equal to, this is another column obviously of type string, and I don't want to index this one. I don't want a primary key. That's it. And one more important thing which we want to do is when you extend this from the base class, this becomes your database table. So we need to specify the table name for that. So I will do underscore underscore table name underscore underscore is equal to, my table name will be courses. So we will see this table going into this one. Statement seems to have no effect. That's fine. The Python did not recognize what that is. Right. So I'm only dealing with just one table for now. Equal to. So I'm only dealing with just one table for now. That's all I need in this file. I don't need anything else. Now let's quickly jump on to our main file where we actually write our fast API code. So what we want to do this in this main file is from fast API. As usual, we want to import the fast API first. And while we are here, let's just also import the exception. And I'm going to add some dependency injection as well. I will show you what dependency injection is. That one. And from Pydantic import, we want to import the base model. And what else do we need? We need to import, again, from database. I want to import engine and the session local variable. We have created the session local, and we also include from typing import annotated. I will show you what this annotation is in a bit. And I want to import all the models obviously from the models file. because I want everything, I'm importing it as models. If we want specific stuff, we can do like this similar way, from models import courses. But I'm doing everything here. And we need SQL alchemy.orm import session. I think that's all we need for now. But if we need anything, we'll come back to this and attach this. The first thing we want to create is an app variable with fast API. That's it. We got it. Now that we have created the database file, we have created the models. The first step we want to do is to create those tables in the database. That is the first step we want to do. So one thing I want to highlight here is, if you're coming from a C sharp background, consider this one as code first approach. And it's not just related to C sharp itself, for any programming language. It's a code first approach. So you write the code first, and then you will create the databases out of your code. So I've created the model. Now I have to create the table out of my model. For that one, what I have to do is, I've imported models here. So models dot my base model dot base dot, we want to do the metadata dot create. I don't know why the IntelliSense is not working here, but this is the right code. Create all, and what we want to create, we have to bind the engine which I have downloaded, which I have created in database. I mean, in the database.py file, that engine we have to get it here. So what this step does is, it will create all the tables that are there in this models file into our Postgre database. So it looks good so far. Shall we just go and run until this point? Let's do that. So in order to run this one, just navigate to your folder and then use the command uvcon. And what is the Python file name? Main. What is the fast API app name? App. And then hyphen hyphen reload. So it reloads continuously. Okay. Application startup has completed, and it is saying that I can see that API in this URL. If I type this one, it says not found. Cancel. That's okay. Let's go to docs. So there are no APIs available. Of course, we have not written any endpoints, but the API itself is running. Let's go to PostgreSQL and see if the tables are actually created. I will give a little refresh on this database and go to table. Yes, this time you see the courses table is created, and we have the columns as well: ID, title, and description. Cool. So we can start writing our API now that the database is created. So the first thing we want to do, of course, app.get slash. So in this video, I'm not going to add those summary, description, name, and all stuff. I want to keep this video short, but you can always go back to my previous video and refer it there, where I have extensively explained how to create fast APIs in a preferred way. Okay, and I want to get underscore all underscore courses. This one, okay, I can't believe I forgot to create the dependency injection. So I want the dependency injection here. That's all right. Let's do the dependency injection here. So first we want to get the database, right? I'm calling it get underscore db, but you can call whatever the name you want. So db is equal to session local, and then we can do yield db, yield, yield db. We can do this one, but the better approach is to close the connection every time. So I will do try yield db, and finally I will add a finally block where I want to do db dot close. So the connection is closed and it's not left open. And here we want to do the dependency injection. So dependency injection is basically all the dependencies that we want to add at the start of the application, when the application starts the first time, and we can just get the references to those in the constructor, or in this case in the API endpoint itself. So it's an inversion of control. If you remember the solid principles, the last principle D is dependency injection. So that's what we are doing here. So let's do db underscore dependency, dependency dependency is equal to annotated of, what is my annotation, my type is session, and it depends on what, get underscore db. This is not a function, this is just a get underscore db. So what this annotation do is it will add some, it is more like an alias name to our session. So if you don't want to use this annotation, you can just do, when we are getting the db here, we can just do db session is equal to depends get underscore db. So I will just do this way first to show you, and then I will show you the better way of doing it with the dependency injection. I mean, using these annotations and the right way. It's not right way; it's a better way in terms of the code readability and stuff. So we want to do the get all for now. Okay, where is my data? Where are our courses? So I will do courses is equal to, I want to do the models dot, this is my table, the courses table dot, okay, we'll do it the other way. It is not creating. I'll just query the database, right? We just query the database here. Simply we can do db dot query. What do you want to query? We want to query the courses in our model, models dot courses, and we can do all, so return everything, and then we can return courses here, or instead of creating another variable, I can straight away return this, right? This should work. Let's go to the browser and see if this really works. Is happening here. And this is @app.get. That's why. Okay, now if I refresh, I will have this get all courses, and we can try it out. Again, no parameters. Execute this straight away. So I got empty response because I don't have any data in my database yet. That's why you got an empty response, but we can confirm that it is working. Okay. Now let's do a create operation. Let's create a course. For that one, what we need is the post method, app.post. Oops. Want to do a slash. You can create a name here, but even if you don't do that one, if you're calling a post method in this route, then it will automatically go to this URL, to this endpoint. I will show you later. If you have more than one post, then you have to specify the routes here. But if you have only one post, then you don't have to specify a route path here. It will automatically come to that place. Okay. Now create course is what I want to do, and I have an input variable, input parameter, which will be course I'm expecting, and then we need the database. Okay, the dependency injection. Let me show you. So this is db dot dependency session is equal to depends. But when we do it the annotated way, this is the type. We are giving an alias called db underscore dependency. So we can just do here db underscore dependency. So it looks more cleaner now instead of having the dependencies there. Okay, db is equal to db underscore dependency. Okay, I got this variable. Now let's write the actual code. The first thing is db underscore course. I have to create the course object on my table. So my table is models dot, what is it complaining here? Course. Okay, I have not created model for course. How sad. Let's do that now. Let me create the model. I have created the database model, but I have not created the pydantic model for internal use. So I will do class. I'm just writing it here, but if you want your code to be clean, you can just move it into another file, maybe call it entities or view models, whatever. And my columns are, the first one id is integer, and then title is str, and description is also str. Okay, I got this one. Now this course is gone. Okay, now models dot courses. So this is my table. I need to add a record into this table. I need to add an item. So what does this expect? This is expecting a title. So my title is obviously post or title, whatever I received from the caller, and description. Description will be post or description. Okay, I will just put an enter here, so this will be readable and does not go out of the screen. And what I need to add is add this course to the database. So db dot add, we want to do db underscore course, which we have just created here. This is not double bracket, it's just a single bracket here. So I've added this to this one. I have to commit this to the database. To do that, I will do db dot commit, and let's just return the course that is created, db underscore course. All right, that's all we have in this now. Let's see if this works. So I've come here, get all courses, come to create a course. I will try it out. So we'll think about this id later, but for now I'm just not passing the id. So title is python course, and some sample description. This is python course, and then execute. Does that work? Yes, it did execute. The response body is nothing. So this is actually done, but we did not get a response. Let's stick it in PostgreSQL. I will tell you what the problem is, and go to table, go to the table courses, and not count rows. I want to select all rows. So this one here, it is edited. I mean, here it is created. The item is there in the database, but it did not return in the response. That is because we did not refresh the data. If I do db dot refresh db underscore course, now it will refresh the database and it will have the latest item here. Let's try it one more time and try it out. My new thing will be python advanced, advanced, and advanced python course. Let's execute this. See, when I did a refresh on the db course, the table itself is refreshed and we got the created item back. If you see, the id is also written, although we did not get the id from the request. the request body. Once the data is created in the database, once it is committed, when we refresh, it will fetch the latest ID as well for us. So that's how this PostgreSQL works. And we will do one more thing, which is the one which we have done previously by getting the course by ID. Okay, slash, and my path parameter will be course underscore ID, and define get underscore course underscore by ID. What do we need? The course ID, which we just got from the request itself, that will be of type int, and then obviously the dependency, db underscore dependency. So we have to query the database here again, like how we did here for get all courses. I'll just do that one. Return db dot query. What do we want to query? We want to query models dot courses. Typo here. This additional brackets are killing me. Okay, now that we have done this one, it is returning all of that. Whereas here, we don't want them to return everything. So we got all the courses. We can add a where condition in SQL. Similarly, in SQL Alchemy, we can use apply the filter. So what is my filter? My filter is models dot courses dot id, the id which is equivalent to the course id which I got from the path parameter. Okay, and dot first record. What is happening here? Model.courses.id is equal to course.id. That looks good to me. Why is it complaining? Say expected column element bool, got boolean instead. What's going on here? So db.query models.filter models.courses.id is equal to course.id.first. It looks good to me. Integer id column expected, the column element bool has cost element, expression element, lambda element got bool instead. Did use a double equals to. We will see what the issue is in a while. Let me try this. Will this run? I want to see. Okay, get all courses, get course and course by course ID. If I do the ID 1, execute, so 1 is written. So it's just some compiler problem there. There is no problem as such in the code itself. Once I restart, it should be cleared. So if I press 2, I got the advanced Python course here. Like how we have done in our previous tutorial, we can just do course is equal to this one, and if there is no item found, then the course will be null. So if it is course, then I will return course, else I will raise a HTTP exception, which is status code 404, and the detail will be no course found. That's it. Now refresh, come here again, try it out, and then do the course. Let's say 5. We'll get an exception here. So that's it I have for this video, just to keep this video short, but I will post this code in GitHub where you will actually see the update and delete also implemented. So update is basically there's nothing special about this update. It just we query the course like this. Once it is there, we can update the details for this course and push it back to the database. That will be a bit self-explanatory. I will post the code to the GitHub just to keep this video short. And maybe in the next video, we'll come up with a new topic. Until then, have a good day. Thanks for watching. Bye.